Now let's implement the sum of 5000 number using fork join. Now to do that, we'll be creating a new package. So the package name is com.modernjava.threading.fork join. And inside this fork join, let's create a new class, new Java class, and class name is fork join sum. This fork join sum will extend the class recursive action. And it is complaining about implementing methods, so just implements the method compute void. Now inside this, the first thing what we'll do is that we'll be creating a variable public static long total, and this is the total which we'll be calculating using recursive action, and private static final integer calculate underscore sum underscore threshold is equal to 5. So this is the calculate sum threshold. This value will be using if our array list or the list basically goes under the size of this threshold, then calculate the sum. As you know that with the fork join, we'll be dividing the main task into subtasks. So this is saying that when the subtask or the list is less than the threshold, which is 5, then calculate the sum. Now now create a list, which is our list, which will be holding all the values from 0 to 5000 long, and this is data. Now let's create a public constructor, public fork join sum, and this fork join sum will take the list as an argument. And this dot data is equal to data. Now let's implement the public static void main, public, or use PSVM. And inside this, the first thing what we'll do is that we'll define the end of the integers, like the list of integer is 5000, so we are keeping it in the variable. And we'll be creating this list long using int stream. Actually, we'll be using long stream because we have a data type of long with list. So long stream dot range closed 0 till end, and here, because this long will give us the primitive type long, and we need to convert this into a long object, so we need to use boxed. This box will convert this integer or the long primitive type to long object, and then dot collect and collectors dot toList. So this will give me a list of integers from 0 to 5000 in this variable data. Now let's create a fork join pool, and pool is equal to new fork join pool. And let's print out our parallelism, like how many cores of CPUs which we have. So pool parallelism plus pool dot get parallelism. Okay. Now we'll be initiating the class fork join sum. So fork join sum and task is equal to new fork join sum, and we'll be passing on the data which we created to this one. And now pool dot invoke, so we are invoking this task now, and at the end, once this task is completely over, we are printing out the total. So total is plus total. This is the total which we have defined earlier, and that variable will be holding all of our total for integer from 0 to 5000. And correct sum calculated, and here we are comparing it with the calculated sum using a string is plus long string dot range close 0 till end dot sum. Now let's start implementing the compute method. So inside the compute method, first of all, what we do is that if data dot size is less than, if the task is split such that the size of this data is less than calculate some threshold, then in this case long sum is equal to compute sum directly, and we'll be printing out sum of plus data dot to string, so we are converting this to string for printing it out, plus is plus sum. Now let's implement this compute sum directly. Create method compute sum directly in fork join sum. So here we'll be looping through the list and calculating the sum. So for long L data and sum is equal to sum plus L, and here total is equal to total plus sum, return sum. So we'll be instantiating a lot of instances of fork join sum until it breaks down to tasks which is less than calculate sum threshold, so that it can calculate the sum, and every time we'll be passing on the data which is a subset of the data, and we'll be implementing this now. So here let's put else, and inside else what we'll be doing is that we'll be calculating the mid. So we are splitting this into two tasks, and then a recursive loop will go and then split those tasks into subtasks of divide by 2. So integer mid is equal to data dot size divided by 2, and then fork join sum first subtask is equal to new fork join sum, and here we'll be passing on this data dot sublist initial 0 till mid. So we are creating a sublist and then passing on to the fork join sum, and then fork join sum second subtask is equal to new fork join sum, here data dot sublist mid and data dot size. So first subtask has half of the element and second subtask has the rest of the half of the elements. And now what we'll do is that we will do first subtask. So we'll be queuing the first subtask using .fork method. So it is queuing the first task and computing the second subtask dot compute. So compute the second task and first subtask, wait for the first subtask to finish. Now that's all for the implementation. Now let's go through this program one more time. So let's start with public static void main. So we are creating a list of long data is equal to long stream dot range close 0 5000 and we are using dot box because this stream will hold primitive value and list holds object. So that's why we have to use box to convert them into object. And then afterwards I'm using dot collect method of a stream to collect that as a list. And then I'm creating an instance of fork join pool and printing out the parallelism, like how many subtasks it will run. So my computer has 4 core CPU, so it will print 4. And then I'm creating an instance of fork join sum, which is this class, and passing on the data, which is the list of 5000 numbers. And then I'm calling pool.invoke. And I'm printing out at the, so this pool.invoke will wait until all the tasks are finished, and then afterwards I'm printing out the total and then calculate the and then the correct sum calculated using a stream sum method. Now here in the compute method, so if the subtask size is less than the calculate sum threshold, which is less than 5, if in this data object we have a value of less than we have a list of less than 5 objects, then calculate the sum using the compute sum directly, and then afterwards print out the sum of that sum and also print out the values within this object. Here I am dividing the list into I'm dividing this data object into 2 and passing it on to the first subtask, which is the full join sum, and then this subtask will have the list from list element from 0 till half of the list, and the second subtask will have the elements from half till the end of the list. And then I am queuing the first queuing the first subtask with fork. This is asynchronous. I'm telling it to fork it, and now calculate the or compute the second subtask. So this is fork to run it asynchronously, but at this point compute the second first subtask first, and it will be running in parallel. But this has the high priority at this point. I'm saying that okay, compute it now, and this is synchronously. And then afterwards, I'm waiting for join. I'm waiting for the first subtask to finish, and that's what I'm calling the join. Now let's run this program. And you can see that the sum which is printed out is equal to the sum which was calculated from the string.